Okay, this tutorial is about balancing chemical equations. So we know that according to the law of conservation of matter, that matter cannot be created or destroyed. So that means if we start with a certain number of, let's say, nitrogen, we should end with the same number of nitrogen. They cannot just disappear, and we cannot have atoms appearing out of nowhere. So in this example, I have 2 hydrogen on this side, I have 3 on this side. So what we need to figure out is what ratios are going to react to form some amount of product. So you can think about a chemical reaction like a recipe. So how much nitrogen do we need to add? How much hydrogen do we need to add? And how much NH3 or ammonia are we going to get out of the reaction? Okay, down here in the parentheses, we have the states of matter. We will not be covering in class how to determine the state of matter. I will give it to you, but if you see G, that means gas. Okay, down here you'll see liquid. We also have S for solid, and AQ means aqueous, so that would just mean that it's something that's dissolved in water. Okay, so to start the problem, we always need to take inventory, meaning we need to count up how much we have of each thing on each side. So I like to write the elements that I'm dealing with right underneath the arrow. This means yields. That way I can count side by side how many of each element I have on the reactant side, which would be on the left side of the equation, and how many I have in the products, which is on the right side of the equation. So in the reactants, I have 2 nitrogen. I also have 2 hydrogen. Okay, these are some of the diatomic elements, di meaning 2, atomic meaning atoms. So whenever you see hydrogen, nitrogen, as well as some others, they will never be just by themselves. They will either be part of a compound or there will be 2 of them hanging out together. I kind of think of them as the needy elements. Okay, so on this side I have 1 nitrogen, so products I've got 1 nitrogen and I have 3 hydrogen. Okay, so there's 2 different ways that you can approach this. One way would be to just start at the top and go ahead and make sure that you have the same number of nitrogen on each side. Another way to think about it is that you have an even number of hydrogen in the reactants and an odd number in the products. Anything that I multiply by 2 is going to give me an even number. So I'm going to make the odd side even, or I can think about it as I'm balancing nitrogen. So because I have 2 nitrogen on the reactant side, I want to make sure that I have 2 nitrogen on the product side. Now, you cannot change any of the ingredients. Okay, so this is what we're going to get out of our recipe. This is the things that we're putting into our recipe. Okay, if you were baking, using a baking recipe, you would never change the ingredients because it's not going to come out the same. So what we're trying to figure out is how many nitrogen molecules, how many hydrogen molecules are going to react to get some amount of ammonia molecules. So what I'm going to start by doing is putting a 2 right here. Okay, so that means I have 2 NH3 molecules. Okay, 2 NH3 molecules. So this 2 affects both nitrogen and hydrogen. So I have a total of 2 nitrogen, 2 times 1, there's no subscript there, so we can assume that's 1. 2 times 1 is 2. 2 times 3 is 6. Okay, and if we look back at our visual representation, if I have 2 NH3 molecules, that's 1, 2 nitrogen, 3 plus 3 is 6 hydrogen. Okay, so nitrogen is now balanced, but hydrogen is not. So on this side of the equation, the reactants, I should also have 6 hydrogen. So what I'm going to do is I'm going to multiply this by 3. So now I have 6 hydrogen. So what this recipe calls for is 1 nitrogen molecule, 3 hydrogen molecules, and we're going to get 2 ammonia molecules. So for every 1 nitrogen, we need 3 hydrogen. Okay, and later on we're going to refer to these coefficients as the number of moles that react. Okay, next example. I have hydrogen and oxygen. So this reaction is the decomposition of hydrogen peroxide. Okay, this is the stuff that we put on our cuts. It actually kills certain types of bacteria. So we have 2 hydrogen in the reactants, 2 oxygen in the reactants. I have 2 hydrogen in the products. Now, and for oxygen, remember we have to count up the number of oxygen on this entire side of the reaction. So I have 2 here plus 1. So that will be 3. So when you add them up, you need to make sure that if there's a plus sign in between 2 compounds, you must include all of those numbers when you're adding them up. All right, so we're back in a situation where we have an odd number of oxygen on one side of the equation and an even number on the other. Anything I multiply this by is still going to be an even number if we're doing a whole number. If we did a fraction, then we could get an odd number. Okay, so I'm going to try to make the product side into an even number. So what I'm going to do is I'm going to multiply the odd number oxygen by 2. Okay, so I'm saying now I'm going to use 2 water molecules are going to come out of the reaction. So I have 4 hydrogen, and I have 2 times 1 is 2, plus 2 is 4. All right, so now we're going to go back to the other side of the reaction. I have 4 hydrogen in the products and only 2 in the reactants. So if I put a 2 in front of hydrogen peroxide, now I have 4 hydrogen, 4 oxygen. So the reaction is now balanced. So your answer is 2H2O2 yields 2H2O plus O2. So in other words, I have, for every 2 hydrogen peroxide molecules, I will get 2 water molecules and 1 molecule of oxygen gas. All right, so this type of reaction is called combustion, when we have a hydrocarbon reacting with oxygen to form carbon dioxide and water. These tend to be the hardest to balance, so I'm just going to walk you guys through how I would approach this type of problem. And I follow the same procedure when I balance any combustion problem. So let's first add up the elements that we have. Okay, I have 2 carbon, 2 hydrogen, and 2 oxygen in the reactants. I have 1 carbon. I have 2 plus 1 is 3 oxygen, and 2 hydrogen. Very, very often when we have a combustion reaction, we have an odd number of oxygen on one side and an even number on the other. So before I even look at trying to figure out how to balance all the rest of this, the first thing I always do when I see this type of reaction is I make the odd side even. So I always start by putting a coefficient of 2 in front of water. So now I have 4 hydrogen, 2 times 1 is 2, plus 2 is 4. All right, so the next thing I always do, if I see that there's really nothing I can do at this point, I don't really know how I'm going to balance the reaction. Well, actually, let's start by balancing carbon. Well, okay, no, let's approach this the way I usually do. Okay, so you could try to balance carbon next, but I'm going to tell you right now, if you tried to balance carbon next, you're going to end up having to change that coefficient. So I always start by putting a 2 in front of water. Next, I'm going to put a 2 in front of the hydrocarbon. Okay, so hydrocarbon meaning a carbon and hydrogen containing compound, carbon and hydrogen. So if I cannot balance the reaction once I've put a 2 in front of water. Then I try to put a 2 in front of my hydrocarbon. So let's add these back up. I have 4 carbon. I have 4 hydrogen. Okay, so now hydrogen is balanced. We're going to leave oxygen to last. Always leave oxygen to last. It's over here by itself, so it's going to be easy to take care of. So what do I need on the product side so that I have 4 carbon on the product side? So I'm going to put a 4 right here. Okay, so 4 times 1 is 4. Okay, 4 times 2 is 8 oxygen plus 2 times 1 is 2. So I have 8 oxygen here, I have 2 oxygen here, so that's a total of 10. All right, now we need to check to see what we can do on the reactant side so that I have 10 oxygen reacting. So if I multiply oxygen by 5, now I will have 10 oxygen. Okay, so we're using coefficients to balance the equation. How many of each ingredient do we need, and how many products are we going to get? So for every 2 molecules or 2 moles of C2H2, which is ethylene, we'll react with 5 molecules of oxygen to form 4 molecules of carbon dioxide and 2 molecules of water. So for every 2 of these, I need 5 of these, okay, and that will produce 4 and 2.